Hilchos Kidush haChodesh, chapters 12 and 13. In the beginning of chapter 12, the Rambam states that in 24 hours, the sun proceeds in the Galgal HaMazolos a distance of 59 minutes and 8 seconds, almost an entire degree each day. As explained in the previous lesson, together with its daily westward revolution around the earth, the sun also moves eastward, propelled by its own sphere. Based on the daily figure stated above of 59 minutes and 8 seconds, one can calculate the angular distance traveled by the sun in 100 days, a year, or many years. In Halacha Beis, the Rambam gives the sun's exact position on the third day of Nisan in the year 4938 after creation. Having established this starting point, one can determine the Emtza HaShemesh, the sun's mean location, on any given date, simply by taking the figure mentioned above, 59 minutes and 8 seconds, and multiplying it by the number of days that have passed since the date of the starting point. This will give the location of Emtza HaShemesh at 6 p.m. on any given date. Nevertheless, further calculations are necessary to determine the exact location of the sun. Emtza HaShemesh is the sun's location on the path of its orbit. Notice, the earth is not in the center of the sun's orbit. The point where the sun is furthest from the earth is called the Gova, apogee. When the sun proceeds a certain angular distance on its orbit, it will not be seen at that same angular distance from the earth. Our model is exaggerated in order to make the concept clear. For example, when the sun is at 30 degrees on its orbit, it will be seen at 25 degrees from the earth, a difference of 5 degrees. This is the Mokum Amiti, the true position of the sun, as seen from earth. At 60 degrees in its orbit, its Mokum Amiti will be 50 degrees, the difference of 10 degrees. At 90 degrees, its Mokum Amiti will be 78 degrees. This is the greatest extent of the difference. From 90 to 180, the difference will begin to decrease. At 180 degrees, there will be no difference. After 180 degrees, instead of subtracting from the angular distance, we will begin adding to it. In chapter 13, the Rambam gives a table to compensate for the variation between the sun's position in its path and its true position as seen on earth. These are the Monois HaMaslul in Halacha Dalid. One further factor must be considered in order to determine the true position of the sun. The path of the sun and the Gova also move. That movement is very slight, as the Rambam states in chapter 12, Halacha Beis. It is 1 degree in 70 years. Nevertheless, this causes the variations calculated above to take place at different angular positions. So, to find the true position of the sun, we must calculate where the sun is in its orbit, and also where the Gova is. Having determined the distance between them, we can now implement the Monois HaMaslul to find the Mokum HaAmiti, the true exact position of the sun as seen from earth.